Hello friends, let us solve another example, another previous year GATE question. So first understand what is the given data. Two different types of soils, okay. Soil 1 and soil 2 are used as a backfill behind a retaining wall. Okay, fine, as shown in the figure. What are the properties if you see? It is a cohesionless soil. In soil 1, 5 value is different. In soil 2, 5 value is different. So weight density is 15 kilonewton per meter cube. Weight density is 20 kilonewton per meter cube. Okay. Gamma D is given. Okay. C and phi are given. Okay, fine. What they are asking? The resultant active earth force per unit length acting on the wall. So what they are asking? They are asking the active earth force per. That means here you have to find out the area under the pressure diet. So here, if you remember, how can you solve it? Is there any water table here? No. But we can simply solve this problem. Why? Because as there is two different soil layers, we have to consider a point just above the layer. We have to just consider a point below the layer, isn't it? Now, at this, what is the pressure acting here? What is the vertical stress here? So before that, in this layer, soil 1, what is the vertical, what is the active earth pressure constant? In the layer, soil 2, what is the pressure constant? So that we have to find out first, isn't it? So in this layer, how much the value? Phi equal to 30 degrees. That means whatever the Ka in soil 1, that will be equal to 1 minus sin phi divided by 1 plus sin phi. If you substitute phi equal to 30, so how much you will get? You will get it as 1 by 3. If phi equal to 30, again substitute phi equal to 30. Then you will get a magnitude of 0.21, 0.217. That's it. Now, let me draw it. Let us assume there is a retaining wall. Meter height. At this top layer, whatever the vertical stress, your vertical stress that will be equal to 0. Then whatever the pressure, active earth pressure will also be equal to 0. Just a point above or just a point below, whatever the vertical stress, that will be equal to whatever the magnitudes, 15 into 2. So vertical stress will be equal to 15 into 2. That will be equal to 30 kilonewton per meter square. So whatever the pressure just above of it, that will be nothing but a Ka1 into sigma V. Whatever the stress just below, Ka2 into sigma V. So whatever the Ka1, 1 by 3 into 30, you will get it around 10 kilonewton per meter square. Let us assume that will come around here. Now join these two by inclined line. So here what is the magnitude? 0.217 into 30. Then how much you will get? You will get it around 6.2 kilonewton per meter square. That is comes around here. So similarly, again it will vary linearly. Whatever the vertical stress here, that will be equal to 15 into 2 in the soil 1 plus whatever in the soil 2, 20. 20 into 2. How much you are getting? 40 plus 30, 70 kilonewton per meter square. Whatever the vertical stress here, that will active earth pressure, 0.217 into 70. How much you are getting? You are getting around 15.19 kilonewton per meter square. Again join these two by straight line. Now they are asking the force. What is the active earth pressure force? That will be equal to whatever the area of this pressure triangle. Let us say if this is in soil 1, in soil 2. In soil 1, what is the area? In the form of triangle. A 0 plus, what is the remaining intensity? 10. A plus B by half into B into H. Half into whatever the base, 10, into whatever the height, 2 plus. In the second portion, it is like a trapezoidal. If it is a trapezoidal, whatever the area, A plus B by 2 into H. What about one intensity? 6.2. Another intensity, 15.19. A plus B by 2 into whatever the height, 2. If you solve this, you will get it around 31.7 kilonewton per meter. Now see the options. So 31.7 is the correct answer. Okay, thank you.